go over the review problems for Chapter 5. So number 1, the National Center for Health Statistics reported that of every 883 deaths in a recent year, so there's a total of 883 deaths, 24 resulted from an automobile accident, 182 from cancer, and 333 from heart disease. What's the probability that a particular death is due to an automobile accident? So all that you do here is you take 24, which is the number from the automobile accident, and you divide it by 883, which 24 divided by 883 is 0.027. 0.027 is the probability. Next, a study of 200 computer service firms revealed these incomes after taxes. That income after tax for these computer firms, 102 were under 1 million. 61 were 1 million to 20 million, and 37 were 20 million or more. What is the probability that a particular firm selected has 1 million or more in income after taxes? So right here, what we have to do is we have to take 61 and add it to 37. So that right there is going to be 98. That's the number that are 1 million or more. And then you take equals 98 divided by 200, and that's going to give you 0.49. So 0.49 is the probability that a particular firm selected has 1 million or more in income after taxes. Next, a firm offers routine physical examinations as part of a health service program for its employees. The exam shows that 8% of the employees need corrective shoes, 15% need major dental work, and 3% need corrective shoes and major dental work. Okay, so let's look at this. 8% need corrective shoes. Let's see, 15% are dental, and then we also have both. So the ones who need just corrective shoes, or the individuals who need corrective shoes, is 8%. 15% need dental work, and then 3% need both. So what is the probability that an employee selected at random will need either corrective shoes or major dental work? The big word here is or. When you see or, you're using the rule of addition. So what we're saying is, what is the probability that an individual needs corrective shoes or dental work? So in order to do this, you have to add 8% plus 15%, but you need to subtract the 3%. If you don't subtract the 3%, then that 3% is going to be counted twice. Because the 3% is part of this group and it's also part of this group, so you need to make sure to only count it once. So equals 8 plus 15 minus 3 equals 20. So the probability is 0.2 is the probability of randomly selecting an individual that needs at least corrective shoes or dental work. So a survey, let's go on to number 4. A survey of top news executives revealed that 35% of them regularly read Time magazine, 20% read Newsweek, 40% read U.S. News and World Report, a total of 10% read both Times and U.S. News and World Report. What is the probability that a particular top executive reads either Times or U.S. News and World Report? So same exact thing. We do Time, which is 35, and then both, let's do 20, or Newsweek, which is 20, and then U.S. News, which is 40, and a total of 10% read both Time and U.S. Report. So Time, let's move this right here. Both U.S. News and World Report and Time. Okay, so what is the probability that a particular top exec reads Time, or U.S. News and World Report. So what's the probability that they're going to read either Time and U.S. News and World Report? So Newsweek is in there just to throw you off a little bit. So let's take a look at these. In order to do this, we have to do equals 40 plus 35 minus 10. Once again, we're subtracting 10 because the 10 is in both the 40 and the 35, so we want to make sure to only count it once. So that's going to give us 0.65 or 65%. So the Newsweek, like I said, it's just there to throw you off a little bit, but really what we're asking for is what's the probability of them reading at least U.S. News and World Report or Time. At least them doing one of these two things. So they could be doing this, they could be doing this, or they could be doing this. Okay? I'll leave that up there for you. Next, a study of National Park Service revealed that 50% of vacationers go to the Rocky Mountains. Once again, same thing. Rocky Mountains. 50% visit the Rocky Mountains, visit Yellowstone Park. Well, this is a little bit different. Sorry. So 50% of the vacationers going to the Rocky Mountains visit Yellowstone Park. 40% visit the Grand Tetons, and 35% visit both. Okay. So, sorry, we're going to do Yellowstone. And I said that we were never going to do this problem again, but I guess we're doing it. 50%, but these numbers are different. So 50% visit Yellowstone Park, 40% visit the Grand Tetons, 50, 35, and then both. What's the probability that they're going to... Sorry. Gosh, I'm getting all these numbers mixed up. So 40%. So in order to do this, what is the probability that a vacationer will visit at least one of these two magnificent attractions? You do equals 50 plus 40 minus 35, which gives you 55%. So we added Yellowstone and Grand Tetons, and then we subtracted the both. So once again, what is the probability that an individual will visit at least one of these two? So that's the same as or. And then right here, what is the probability? Notice the word or up here. And so these are all using the rule of addition. Okay, so moving on, a sales rep calls on 4 hospitals for number 6 in Westchester County. It's immaterial which order he calls. How many ways can he organize his calls? So here we're just using the multiplication formula. And so basically there's 4 different calls that he can make in the first one. So we're just do 4 factorial. Equals fact 4, and that's 24. Okay, if there's 4 different hospitals, and we're trying to find out the number of ways he can call each hospital, if it's immaterial in which way he calls them, just do 4 factorial. We are going to do number 7. Giorgio offers a person who purchases an 8-ounce bottle of Allure 2 free gifts chosen from the following. So there's 5 gifts right here. Okay. If you purchased Allure, what is the probability that you'll randomly select an umbrella and a shaving kit in that order? First of all, what is the probability that you are going to randomly select an umbrella first? So there's 5 gifts, and so what's the probability of you selecting specifically the umbrella? And that would be 1 out of 5. And then, given that you selected the umbrella first, let's do this. So the probability of you selecting an umbrella first is going to be 1 out of 5. And then the probability of you selecting the shaving kit, given that you selected the umbrella, is going to be 1 out of 4. So what you've got to do is take 1 out of 5 multiplied by 1 out of 4, which gives you 1 out of 20. So the answer is 1 out of 20, or 0.05. So you have the prior probability multiplied by the conditional probability, which gives you the joint probability of first selecting the umbrella and then selecting the shaving kit. Next, a board of directors consists of 8 men and 4 women. A 4-member search committee is randomly chosen to recommend a new company president. What is the probability that all 4 members of the search committee will be women? So here you have a total of 12 individuals, and you want to see, they're just randomly going to select from those 12 individuals, they're going to randomly select 4 people. We already know that 4 women and 8 men make up this board of directors. So what's the probability that all 4 members of the search committee will be women? So first, the very first person that you choose, there's a 4 out of 12 chance that that first person is going to be a woman. Next, given that you chose a woman the very first time, the next person would have a 3 out of 11 chance, because there's only 11 people left and there's only 3 women left. A 3 out of 11 chance that they're going to be a woman. And then next you're going to have a 2 out of 10 chance, given that the second person was a woman. So you, the first and the second person was a woman. Now you've got a 2 out of 10 chance that the next person is going to be a woman. And then finally you have a 1 out of 9 chance that the very last person is going to be a woman. Which gives you a total probability, if you multiply all of that together, of 0.002 is the probability that you are going to select all 4 women to be members of the search committee. So a gumball machine has just been filled with 50 black, 150 white, 100 red, and 100 yellow gumballs that have been thoroughly mixed. Sue and Jim each purchase 1 gumball. What is the likelihood that both Sue and Jim will get red gumballs? So what you've got to do here, so the red gumballs is 100 out of, let's see, how many total are there? Let's see, 200, there's 400. So it's going to be 100 out of 400, okay, is the first. So that's the probability that Sue, let's just assume that Sue is going to choose first. So 100 out of 400 multiplied by 99 out of 399. Okay, because we're assuming that if Sue chooses a red gumball first, that it's going to be 100 out of 400. And then there's 99 out of 399 for the very next, because there's only 99 red gumballs left and there's only 399 total gumballs left. So if you multiply the 2 of those together, it's going to give you 0.062. Okay. Next, so 0.062 is the probability. Question number 10, in a management trainee program, 80% are females, 20% are males. 90% of the females attend college. So this right here, we're going to do a probability tree. Okay, so in a management trainee program, 80% are females. Okay, 80% female. And then over here we have 20% male. 80% female, 20% male. 90% of the females attended college. Okay, 90% college, 10% no college. Okay, then of the men, 78% college, and then 22% no college. Okay. A management trainee is selected at random. What is the probability that the person selected is a female who did not attend college? So this right here, we're doing joint probability. So we have conditional, and we have prior, and so we need to make joint. So what is the probability that an individual selected is going to be a woman or a female who did not attend college? So in order to do this, all that you've got to do is do 0.8 multiplied by 0.1, which is going to give you 0.08. And if we wanted to select all of these, or determine all of these, you can do equals 0.8 multiplied by 0.9, which gives you 0.72, and then 0.2 multiplied by 0.78, and then 0.2 multiplied by 0.22. So we've got all the joint probabilities right here. Oops, I don't know why it says, there we go, joint. So these are all the joint probabilities. So this right here is the joint probability of randomly selecting a female who has not attended college. Okay, and there's more information in here with conditional, so on and so forth. Number 11, a supplier delivers an order of 20 electric toothbrushes to a store. By accident, 3 of the electric toothbrushes are defective. What is the probability that the very first 2 electric toothbrushes sold are defective? Okay, so the very first one right here, what is the probability that the first electric toothbrush sold is defective? So the probability that the very first one sold is defective is 3 out of 20. Okay, and then the probability that the very next one is also defective is now going to be 2 out of 19. Okay, so if you do 3 out of 20 multiplied by 2 out of 19, because there's only 2 defective left and there's 19 toothbrushes left, that is going to be 0.01579. Okay, and going to number 12. An electronics firm sells 4 models of stereo receivers, 3 amps, 6 speaker brands. What 4 types of when the 4 types of components are sold together, they form a system. How many different systems can the electronic firm offer? Okay, so you have stereo, and you have, let's see, 4 models, and then we have 3 amps, and we have 6 speakers. So how many different types can they make? And all that we've got to do is multiply the 3 of those together. So equals this times this times this to determine the total number of combinations. Okay, how many different systems can be made? A total of 72 different systems can be made. You just have to multiply the 3 different options together. If we had a 4th option, and say wire, and there's 2 different types of wire, then that would actually double the number, so it would be equals all 4 of these multiplied by each other, so it would be 144 if we were to add another one. Okay, this one's really confusing. Don't do it, just skip it. So yeah, it's a very poorly worded question, and yeah, just skip it. Alright, so how many permutations can be made from the 3-letter word C, or from 3 letters C, D, and E? So you have 3 different permutations. So in order to do this, you pull up the permutation formula. Okay, so the permutation formula is going to be 3 factorial over 3 minus 3 factorial, or 3 factorial over 0. And it's the reason why it's 3 minus 3 factorial is because with a permutation you take the number of objects available, or the total number of objects, and you subtract the number of objects selected at a time, and because all 3 are being selected at one time, you take 3 factorial over so because all three are being selected, you do 3. So it's 3 factorial over 3. Oh, I don't know why it's okay. 3 factorial over 3 minus 3 factorial, which is going to just be 3 factorial, which is 3 times 2 times 1, which gives you 6. Okay, you are assigned to design color codes for different parts. 3 colors are used to code one part. Once a combination of 3 colors is used, such as green, yellow, and red, these 3 colors cannot be rearranged to use as a code for another part. There are 35 combinations. I'm not going to ask you how to do anything like this. So yeah, just skip over that. Basically what this is saying is you've got 3 different or 3 different possible things to choose from, and they said that there's 35 combinations. How many colors are available? And they're just telling you to use trial and error, which that's just annoying. So I apologize for even having that on there. Next, let's bring this down. So each salesperson in a large department store. We just went over this. I went over this in the previous. What's that called? In the previous recording. So I went over all of these right here in the previous recording, and so this one on your sheet is actually going to be should be 17. So an automatic machine inserts, so let's just assume that this one right here is 17. An automatic machine inserts mixed vegetables into a plastic bag. Past experience revealed that some packages were underweight and some were overweight, but most of them had satisfactory weights. Now, in previous problems that we've done, when you, so the question is asking, what is the probability of selecting 3 packages that are overweight? The probability of selecting an overweight package every single time is 7.5. Okay, that is every single time. That is the probability of selecting an overweight package. And the reason why is because I don't give you, there are 100 packages and 7.5 of them are defective. Or in that case, it would have to be, and 8 of them are defective. What is the probability of you randomly selecting the first 3 packages and all 3 of them are defective? That's not what I'm asking. What I'm asking here is what are the probability of selecting 3 packages that are overweight? So, the probability of selecting the first one is 7.5 or 0.075. The next one is 0.075 and the next one is 0.075. So just multiply all 3 of those together and it gives you this fun little number right here. So that is the Chapter 5 review.